Hi everybody, I'm Karthik Ranganathan, one of the co-founders and the CTO at Yugabyte, and I'm going to show you guys about the Enterprise Edition of Yugabyte in action. Okay, we're going to try a few cool things, so let's just get started right away. First off, what is YugabyteDB? Quick recap. Yugabyte is a transactional and high-performance database that is extremely useful for building planet-scale applications. Yugabyte brings together SQL and NoSQL into a single cloud-native database. Okay, so let's look at a couple of different deployments of Yugabyte because it's really good for multi-geographic. Can we?
Yeah, you can just go right there.
Okay. Okay, so let's look at a couple of deployments of Yugabyte in a geo-distributed setup. Okay, the first multi-region service that we talk about when using Yugabyte is one that requires strong global consistency. Examples of such applications are when you build a user identity service where users try to log in and change their password, view their profile, etc., a billing or transactional service, or even a variety of different SaaS applications that you interact with today on a daily basis. Okay, so in such a setup, such applications require data to be present in faraway geographies. They should be able to survive failures of entire regions. They should give globally consistent writes to end users. The writes could originate from any data center. And finally, you need to give low latency reads from the nearest data center. So we'll take a look at setting this up in detail, but YugabyteDB set up in this fashion manages strongly consistent replication and fault tolerance internally. Okay, the second type of multi-regional service, and we'll take a look at an already deployed example of such a service, is one where you want to use read replicas because you want low write latency. So with the previous setup where data is geographically distributed, what you'll find is that writes have to traverse across faraway geographies. There's no beating physics and the laws of and the speed of light, so it will take some amount of time to give you global consistency. Whereas here, we're going to be establishing quorum really nearby, so you'll get low write latency, and you should be able to run your high throughput applications. Examples of such applications are IoT apps, user personalization, a stock ticker example where you have a huge blast of data coming in, and so on and so forth. Okay, so such a deployment, like we talked about, needs GeoRedundancy, so it needs data close to end users so that they can interact with it quickly, and it needs writes to happen at a very high throughput with low latency. So in order to achieve low read latency, we enable reads once again from local data centers, but we keep writes, the quorum of writes, strongly consistent in one data center and use async replication to replicate the data to a faraway region. Okay, so I'm going to go to one of our document pages, which actually will walk us through how to set this up. And we are going to take a look at the deployment number 1, which is the strongly consistent deployment. We're going to look at strong consistency. Okay. Okay, so here's the document page. I've just opened up that link, and this setup is going to walk us through how to set up a geographically distributed cluster across Oregon, Northern Virginia, and Tokyo. So let's get started. What I have here is a deployment of Yugabyte that is set up to work across a variety of different IaaS providers. So public clouds, it supports AWS, Google Cloud, and it's also configured with an on-premise data center. Now, let's take a look at how it works in Google Cloud, say. To create a universe, simply click on the Create Universe button, and you just give your cluster a name. I'm going to call it Strong Consistency. And for the provider, let's pick Google Cloud as a provider, although you could have picked any of the providers. As far as the regions go, let's do the same thing we talked about. Let's have one region, one data center or region as Oregon, another in the east coast of US, and a third in Europe. I'm going to change the machine type to go to 8 cores so we can actually do some real reads. I'm going to increase the replication factor to 5, right? And I'm going to make sure that I have 2 replicas Okay, I have 2 replicas in the US. Because the data is so far away and the RPC times will be much bigger, we want to tell the database to not detect failures prematurely. So we're going to increase the heartbeat interval between the various Raft quorum members. And at this point, we are pretty much done. So we go ahead and hit create and let the system spin up the cluster. So what you see here is that YugaWare, the administration console for Yugabyte, is automatically bringing up a single database that spans 3 faraway regions. We'll have 2 replicas in US West, 2 replicas in US East, and we'll have 1 replica in Europe. Okay, and once the system comes up, we'll find that we'll be able to interact with this database using Redis, using Cassandra, or using Postgres, either of those 3 APIs. Now, what we look at here is the way the system is going to get provisioned. It first creates the nodes based on the cloud provider. It then installs the software, updates the various flags required in order to get the system to get networked together, and finally configures the universe so that somebody outside can interact with it using various database drivers. Okay, so all we did was skip past a few minutes, and now we have the cluster instead of having to wait for it the whole time. But what we have here is now a 5-node replication 5 cluster set up across US West, US East, and Europe. Okay, we find that YugaWare spun up all the nodes in the different regions for us, right? And the tasks of updating the universe finally went to completion, and we're going to now run some workloads. Okay, so back to the documentation. I'm going to scroll down and run a global application. Okay, so first things first, let's go find the nodes and connect to them. So I'm going to connect to 3 of the 5 nodes. I'm going to connect to the first 3 guys here, US West, Europe, and US East. I'm going to connect to the first 3 nodes here. So let me go ahead and connect to the first node. All I do is paste that there and we are in. And connect to the second node. Okay, connected to the second node, and finally let's connect to the third node here. All right, so having connected to the 3 nodes, now let us install the prerequisites. Firstly, going to install JDK. On all the 3. So what we're trying to do here is emulate a real-world application that does reads and writes from the 3 different regions, from US West, from US East, and from Europe. So now that I've installed JDK, let's okay, the next thing we need is to export the SQL, the endpoints that these clusters need to connect to. Now, there is a handy way to find these endpoints. The cluster here actually exposes a view of the different endpoints based on the API that you use to interact. We're going to use the Cassandra API, so we use the YSQL endpoint. And I'm going to put that here on each of the 3 nodes. Okay, and last but not the least, we start the load tester. And the load tester here is doing global writes and reads from the nearest data center, from the local region. So I'm going to first paste these 3 guys and not start the load tester yet. And at this point, go to the nodes. Node 1 is in US West 1. So I'm going to plug that in here. And what you find is that the minute I do that, it's going to connect to the cluster, and it's going to create a table, and it's going to start running a workload. In the meanwhile, I can put in the same for the other 2 regions. Okay, and I'm going to kick off the workload from all the three regions. And what you find here now is that a table will get created and it's going to start interacting with the database. Okay, we find that the workload is just starting to kick in. So in a couple of minutes, we should be able to see it go further. Okay, so we find that the workload has come up here. We find that the selects are like we're doing about 110,000 reads. We're doing about 14 inserts per second at the moment, and the workload is just getting started. What we find is that the insert latency, which is shown in orange right here, is 135 milliseconds because it's doing globally consistent writes, while the read latency is 109 microseconds, so that's 0.109 milliseconds, because we're reading from the nearest data center. And what we will find is that the system will start to continue to stabilize over a period of time running this workload. Now, this was one of the two deployments. Now, instead of creating another database and working through it for another deployment, we're just going to pull up an example of the second deployment, which is equally easy to create. Here we have a 3-node cluster in US West running on Google Cloud, and a 3-node read replica with replication factor 3 running on the East Coast running in AWS. And the workloads, reads and writes are happening from the West Coast, and only reads are happening from the East Coast. And what we find here is that it's doing about 20,000 reads and about 350 writes, 345 writes per second. And the latencies, the write latencies are 1.8 milliseconds, and the read latencies are like 0.193 milliseconds. So this setup gives you low write and low read latencies, whereas the previous setup was a higher write latency but global consistency along with a low read latency. So Yugabyte gives you a variety of different ways to mix and match and get your deployment done to achieve exactly what you want from your application. Okay, so with that, let's wrap up. That was pretty much the bulk of the demo. Okay, so what's next? The setup that we went through today of setting up a globally distributed multi-region application, you could do that across multiple clouds, and you could repeat the same thing with Amazon. You could do it with on-premise, so on and so forth. YugaWare is multi-cloud ready. It can set up in just a few minutes in your own account. And if you just wanted to try the database, you could give it a try on your laptop by going to our documents to the Quick Start section. Thank you for watching, everybody.